I request all of you sitting at the back to kindly move forward and take the chairs in the front, please. All right, without further ado, it's such a pleasure to have you all with us this morning at the Aero India 2025. Esteemed speakers, distinguished guests, on behalf of PHDCCI and Hindustan Aeronautics Limited, I extend a warm welcome to each and every one of you. Indigenous development of aerospace material, strengthening India's self-reliance. As we stand at the threshold of technological advancements and self-reliance, the aerospace industry is a key pillar for strengthening India's defense and manufacturing capabilities. Developing indigenous aerospace material not only reduces dependency on imports, but also bolsters our strategic autonomy and innovative ecosystem. And you, the industry experts, the ones in the industry, definitely know the importance of it. Today, this seminar brings together policymakers, industry experts, and thought leaders to exchange knowledge, discuss challenges, and pave the way forward for India's journey towards achieving self-reliant aerospace materials. We have an exciting and insightful program ahead filled with expert addresses and thought-provoking discussions. So without further ado, please put your hands together to welcome the dignitaries onto the dais. I'd like to request the dignitaries to come onto the dais. We have with us Shri Shishir Kumar Patra, General Manager, Hindustan Aeronautics Limited, to please come onto the dais. We have with us Mr. William Blair, Vice President and Regional Chief Executive, Asia and India, Lockheed Martin Global Incorporation. So please come onto the dais. We also have with us Ms. Joanna Manzi, Senior Vice President, Supply Chain Development, Rolls-Royce. Ma'am, such a pleasure to have you with us. Please come onto the dais. I'd like to invite Shri M.K. Gupta, Co-Chair, PHDCCI, to come onto the dais and officially welcome the dignitaries onto the dais. Sir, for your welcome address, please. We also have with us Shri Sanjeev Kumar, Secretary, Defense Production, who will be joining us in a bit. I would now request Shri M.K. Gupta for his welcome address.
Good morning, ladies and gentlemen. It is my privilege to extend a warm welcome to all of you to this important event of indigenous development of aerospace materials, organized under the theme, Capability Enhancement in Indigenous Manufacturing of Aerospace Materials. On behalf of PhD Chamber of Commerce and Industry and HAL, I am honored to welcome our esteemed dignitaries, industry leaders, and experts who have gathered here today to deliberate on the subject of national importance. A special welcome to our distinguished panelist, Shri Sanjeev Kumarji, who would be joining very shortly, under whose vision and policy direction play a very critical role in shaping India's defense manufacturing landscape. Shri Shishir Kumar Patra, General Manager, HAL, SED Koraput, whose expertise in manufacturing and operational excellence continues to strengthen HAL role in India's aerospace ecosystems. Mr. William Blair, Vice President and Regional Chief Executive, Asia and India, Lockheed Martin Global, representing a global perspective on the aerospace innovation and strategic partnership. Ms. Joanna Manji, Senior Vice President, Supply Chain Development, Rolls-Royce, whose insight into the supply chain strategies are invaluable in enhancing indigenous capabilities. India's aerospace industry stands at a pivotal moment, with self-reliance being the cornerstone of our national strategy. The development of indigenous aerospace materials is not just a necessity, but a strategic imperative to enhance our capabilities, reduce dependence on imports, and strengthen the Atmanirbhar Bharat vision of our Honorable Prime Minister, Shri Narendra Modi ji. This conference provides an opportunity to exchange ideas, discuss challenges, and explore collaborations that will thrive technology advancements in aerospace materials, ensuring India's leadership in the global aerospace sector. I am confident that today's discussion will pave the way for new opportunities and partnership that will catalyze innovations, enhance indigenization, and fortify India's aerospace capabilities. With that, I once again extend my warm welcome to all of you and look forward to inside deliberations. Jai Hind.
Thank you, sir. I would now like to request Mr. M.K. Gupta to hand over a bouquet to welcome Shri Shishir Kumar Patra. I'd like to request Shri Shishir Kumar Patra to hand over a bouquet to Mr. William Blair. I'd like to request Mr. M.K. Gupta to hand over a token of appreciation to Ms. Joanna Manzi. A hearty welcome to everyone. I would now like to request Shri Shishir Kumar Patra, General Manager of HAL, to set the context and give the Indian perspective on the subject. Sir, I'd request you to take the other podium, please.
Very good morning to one and all. Honorable Secretary Defense Production, DDP, MOD, Sri Sanjeev Kumarji, who will be joining now. Then dignitaries on the dais, Sri Chawlaji, DGQA, and other dignitaries and participants and speakers. I feel myself honored to stand before you and speak something about aero engine, indigenization, about indigenous aero engines. See, for decades, at HL we are making aero engines. Maybe from 1960s onwards we are making the aero engines, starting from generation 2, generation 3, generation 4. Now we are manufacturing generation 4 plus engines. But now also we are dependent on import for the materials. Whatever the materials we use, these are mostly indigenized, these are imported. And now we are in the process of indigenizing. This will give a boost to our Atmanirbharita Bharat, and it will, in the long way, it will help India. This is the aero engine which we are using for our Su-30 aircraft. It is a twin-spool turbofan engine, and it has got different facilities. It is a multi-purpose engine. It can operate in different modes like training, combat, and special modes. And it has also got a thrust vectoring facility. Like in any jet engine, there is a jet nozzle which gives the thrust, and this thrust, with respect to the jet nozzle, it can be tilted. So, because of this section, our Su-30 aircraft, it can have a cobra motion. The duck fighting and all this thing, it becomes very easy, and it becomes very handy for a pilot to maneuver. So, this is one of the unique facility that we are having in India, only this engine and this aircraft. Then it has got a dedicated electronic controller, and also it has got a surge protection mechanism. Many of the older engines, they were not having surge protection. So many times it used to, because aero engines, especially the fighter jet engines, they operate in a very unstable condition. Any change in any parameter may lead to unstable operation of the engine and may lead to failure of the engine. And it has got a unique surge prevention system and also anti-icing. Anti-icing which helps in high altitude flying and flying at high altitude also. This is the basic construction of the, if you see from the inside, this is the engine. Any pointer is there? Okay. You can see first is the compressor side. There are two compressors. One is LP compressor, then HP compressor, then there is the combustion chamber, and after combustion chamber, there is a turbine. Then comes the diffuser. In the diffuser, and as I told, this is a bypass engine. So partially air from the LP compressor, it is diverted away from the HP compressor, and it goes directly and meets the air after combustion chamber. So the mixing of the air just happens before the diffuser, and that cold and rich air with oxygen or air oxygen, it goes to afterburner. Then the afterburning takes place, and whenever required, the engine goes into afterburning mode. These are the various parameters like pressure, temperature, all these things. If you see our engine, it has got 5161 type of components. First is 4240. These are the various components we manufacture from the raw materials. Then there are 40 types of bearings. Then there are many types of spares like 815. Then 58 LRUs, which controls the engine. If you see how the engine is made, the input is the first line. We get the raw material from Russia. No, just wait. I'll tell you. No, wait. Go back. Okay, this video is the jet nozzle, how the jet nozzle is vectored. It is plus minus 14 degree, you can see. And it is not straight, it is at a 32 degree to the vertical. For left engine and right engine, it is slightly different. You can see this is a right engine. So this is how the jet vectoring takes place. Because of this thrust vectoring, immediately it can take a vertical up. Okay, close, thank you. Go to the PPT. No, back. So the first line is the raw materials that we use, like rods, sheet, forgings, pipes, then ring forgings, then disc forging. These are the raw material we get from outside. From there, we do the casting, forging. Then we get our the first one is the single crystal blade. This is the only blade in India that we manufacture which is having a single crystal. Like in any metal we take, it has got multiple crystals. But this is a unique feature. Because of this single crystal, it can withstand high temperature. And there are various types of casting like titanium, magnesium, high temperature alloys, then this is a gearbox, then that is the LPT blade. So after this casting and forging, we do the machining and prepare the components and with the assemblies. And with these assemblies, we assemble the engine. Then it goes for testing. After in Russian engine, there are two tests. One is the initial test. After first test, the full engine is stripped. Then we again check each and every component. If it is okay, then it goes. We again assemble it. It goes for the second test. Then it is finally delivered to services for exploitation. If you see in total engine, there are 237 type of castings, and we have mastered full casting technology. Any type of casting of this engine we can do in India or in-house. Similarly, forging also 9-1 type, which we have also mastered. But this raw material for this are now imported, which are going to indigenize. Second is the critical heavy forging. This is a unique facility in India we don't have. Nobody is having this facility. Like heavy forging, it requires high tonnage plus also isothermal facility. Isothermal means that forging takes place in a constant temperature. During forging, there will not be any drop in temperature. So that facility and this high capacity, nobody in India, we don't have. We at HL, we are going to establish this facility. Then the sheet metal, all components are indigenized, but the material is imported. Similarly, there are many non-metallic components like graphite, some Teflon, all these things are there. Then 58 LRUs, these are also very critical. There are 58 type of LRUs, out of which we can manufacture 23 types, but the 35 types we depend on outside for import. Then there are various type of spares. Out of 815, we have already indigenized 484 and 331, it is in the process. Then 48 types of bearings are also there, which are also very critical. This is the first time we'll be indigenizing the material as well as the bearing. And this is our approach for indigenization. Initially, the LIS forms, heavy forging, they'll be indigenized with the help of HL, Midhani, DMRL, Semilac, NFC, and also private partners. After these raw materials are prepared, then it will be converted to the components by HL, for which we have got full mastery. We can do it. Then it will be, there are some certain testing facility presently we don't have in India, like the compressor discs. They rotate at a high RPM. And because of this high RPM and all this thing, it may fail. So unless we test the forging, whether it is able to withstand that high RPM and high temperature, we cannot put on the engine. So that testing facility also we have to establish for the first time in India. This will be done in coordination with Semilac and also private partners. Then various type component which we have got full mastery will be doing it. Engine assembly we can do it. And also we are going to have specialist test bed, because we are making engines, but when we are making engine from our basic own raw material, so there are certain components also which have to be additionally monitored during testing. So we are going to have a specialized test bed with the help of Semilac, GTRE, and also private partners. Then this engine, it will be subjected to a endurance race. Like presently for our engine, the full cycle time, life of the engine is 2000 hours. Full 2000 hours we run in the test bed. Once it is satisfied only, then it is cleared by RCMA, DGOK, then it can go to services. So this will be done by HL. Then after that, once the engine is certified at Koraput, then it will go for flying test. Because the real engine, it has to go to along with the aircraft, because whatever we do in the test bed, there is some difference between the test bed and the actual flying. So next it will be subjected to flying test. After it is successful, then we can say proudly we have got full our 100% indigenized engine. This is the roadmap, like raw material, then high capacity manufacturing components. These are the types, like in the core engine there are 1385 type of alloy, out of which already we have indigenized 399 with the help of RCMA, DGQA. Then there are some items which are very low requirement, that also we are trying to indigenize, and the main critical items are 902. So out of 902, already 629 types, already we have tendered to Mrs. Midhani. They have, and out of 629, already 30 varieties they have already supplied. And now we are in the process of making the components, and after that component testing will be there. And for that 91 variety also, it is in the process of tendering and placing the PO. And next is the 182 variety. 182 variety, these are like other metals like aluminum, copper, PTFE, graphite, all these things. So these are, we are in the process of finding out our partners for this, supplying these items. And one item very critical is graphite. People might be thinking why graphite is so critical. But graphite quality, whatever is used for aero engine, it is very, very critical. It has got no porosity. Any graphite we say it has got a certain percentage of porosity. And if it had got porosity, it cannot be used as an oil seal. So this graphite with 100% packing density, it has to be first time developed in India. Then till now these are the progress, like material for HP turbine blade, it is under development. Then LP turbine blade, HP NGV and LP NGV already they have supplied the materials to HL, we are in the process of casting. Then HP compressor also they have given. Like this, these are the progress with Mrs. Midhani. And for controlling the engine, there are, I told, there are 58 LRUs. And out of 58 LRUs, 9 are very critical. Like which controls the, which supplies the fuel to the engine and also controls the engine parameters. Like our main fuel pump, NR, RT, there are the Russian names. So, although presently we are manufacturing these controllers in India, but the materials are from Russia. So, these are also under, these materials are also presently under development. Like there are 833 varieties involved. Already you have rationalized with the help of RCM 377 varieties with the existing alloys. Then further indigenized is 36 and balance to be indigenized is 341. This also we are in contact with Midhani and other industries and PTC. Then indigenization of bought out LRUs. Whatever that's discussed, those are we already are manufactured in India, but the material is to be indigenized. But these LRUs, till now we are importing. And the OEM, they have not given the full parameters of these LRUs. So these are the challenges for us, how to, because we know only the parameters. This is the input, this is the output. But inside, what is the working mechanism, we don't know. So this also we are trying to do reverse engineering, and with the help of Indian partners, we are trying to indigenize. Total out of 58, 23 already are manufactured, 35 is important. Out of 35, already we have placed PO for 12 varieties, and many items already we have received. It is in the prototype already we have received, and it is in the testing stage. Then PO to be placed 10, RFP to be issued is 11. Tender stage 1, an in-house development. One, there is a turbostator that we are trying to indigenize in-house with the help of our AERDC. This is the responsibilities who will be doing what. Then this is the high capacity isothermal forging capacity, what I was telling. In India, we don't have this facility. We have done market survey of all the big forging companies, although they do big forgings, but they don't have this high capacity 20,000 ton isothermal press. So this we are going to establish. And next is the test bed that we are going to establish at Koraput, because this test bed will be a 3-dimensional test bed. Because our engine is having thrust vectoring. It gives thrust in all directions, many directions. So we have to also measure the 3-dimensional thrust. So this new test bed, it will be having a facility to measure the thrust in different angles, like X, Y, Z. What our challenges we are facing is, because for these LRUs, we don't have this ICDS. So what I told, we are trying to develop through reverse engineering. Then bearings, till now all these aeronautical bearings we are importing, except a few one. And this bearing is very critical for this our engine also. Most of the failure of our engine is because of the bearing. So this also we require good partners to develop bearing. Then high temperature and strength alloy, then single crystal material. But we are doing the single crystal, but it is with imported material. Now we have to develop the material. Then technical know-how for certification, because till now, for example, the HPD discs, which rotates at 13,000 RPM, and also it is subjected to high temperature. So we don't know at that RPM and that temperature what will happen. So we have to subject to that. So in coordination with Semilac, we have to develop the test procedures, and we have to have test facility for certifying these components. And last but not the least, the import of this high capacity press, because this press is very crucial. It is crucial not only for L31FE engine, it is also for AMCA, all this project. So advanced countries, they would not like to spare this or transfer the technology for this isothermal. So this is also a challenge for us. Maybe you have to develop in-house also. Thank you.
Thank you, sir, for an insightful address. I would now like to request Mr. William Blair to give the global perspective. William is the Vice President and Regional Chief Executive of India and Asia, Lockheed Martin.
Thank you very much. It's great to be here and appreciate the opportunity and the invitation from PhD Chambers, Mr. Mohinder Kumar, and also recognize Shishir Kumar Patra in your presentation just now from HAL, and look forward to the Secretary of Defense production joining us, Shri Sanjeev Kumar. And ladies and gentlemen, I appreciate you being here. What you just saw actually brought me back to my earliest roots. I started out as a mechanical engineer 40 years ago, this year in fact, designing high-pressure turbines at GE Aviation. And so I had some remarks that I was going to make, but I thought I'd frame it by some of the experiences that I've had over a few decades in India. My first trip to India and my visit to HAL was in 1996. GE at the time was on the cusp of building, in collaboration with HAL, LM2500 gas turbines. So the presentation you just saw, I mean, it's been a long time since I've seen, the aircraft engine overview like that, but it, like I said, it takes me back to my roots. But it was an important time because I think what's really important, and from my perspective, is international collaboration and cooperation. And there's a lot of different frameworks, but there's a lot of we can point to as a foundation. So that was a key time, I think, and that's after also HAL was building gas turbines under license, I think, with France on some of the engines, as well as what was being built at the aircraft level. That's the important demand signal and the evolution that's driving the demand for now today, as we sit here looking to increase the indigenization. What can we make in India? And there's a lot that we can do. And the catalyst for that, frankly, is the push from the government of India for Atmanirbhar Bharat, and for us as companies that are seeking to bring our best capabilities in collaboration with India. We need to get to the highest levels of indigenous content. And in large part, that's one of the barriers, if we don't solve it, is actually sourcing the raw material and the forgings and the structures that feed into what we build as components and ultimately either engines or aircraft, helicopters, for instance. 2006, 2007, I visited HAL Foundry and Forge because at the time I was still with GE Engines. We were really trying to increase our supply chain. So if you remember at that time frame, we were all anticipating, that the DPP was just being formulated, offset obligations were going to come with the fighter competition, and so all of the OEMs were seeking opportunities to partner with HAL and other defense public sector units and also the private sector that was coming up at that time. Bharat Forge Limited is another company that was transitioning at that time frame from, I think, being number 2 in the world on automotive forgings, really quite amazing, and moving into the aerospace and defense sector. So I would say one of India's strengths since that time frame is sustaining and growing the defense public sector units, but then the private sector coming up in concert with that and in collaboration with that. And not just the large, but also the hundreds of suppliers that feed into HAL as an example, but also feed into the private sector. And then fast forward to, I came back to India in this role now that I'm with Lockheed Martin in 2019. And here at Aero India in 2020, we signed an MOU with Midhani, because at that time we were seeking, again, under an offset requirement, to see is there something we can do under aerospace and defense materials. We highlighted it as an opportunity and a challenge with the U.S.-India CEO Forum, and saw that was a great opportunity. I should always preface this, when we look at offsets, we look at it out of opportunity, not obligation. How can we take the offsets that are attributed, in this case, to the MH-60 Romeo deal that was done under then President Trump in January, February of 2020, how can we translate that to bringing more capability and transfer of technology and help us position for future campaigns we know today by making those investments in collaboration. That's still a journey and an opportunity that we feel. And then what's an enabler of that? It's the government-to-government cooperation, G to G. Under the initiatives of Defense Trade and Technology Initiative that was kicked off in 2011, or under ISET, Critical and Emerging Technologies, that the U.S. National Security Advisor with National Security Advisor here in India got together, Shri Ajit Doval, and launched ISET as a catalyst for how we can work together on critical and emerging technologies. We need those G2G collaborations to enable us to actually co-invest, basically. We can't, not one company or a company in collaboration with an Indian company can do it alone. If we're looking at titanium, specialty steel, aluminum, superalloys, and composites, the growth of that market globally is all growing at about 6 to 7%. That's a great opportunity not just to meet India's indigenous needs, but to meet a global requirement that, frankly, under the geopolitical environment that we know today, is strained. There's a supply chain resiliency issue. I think India can be a big part of the solution, not just to meet the indigenous requirements of India, but also be part of that global supply chain resiliency. And we speak to it through terms of resiliency, but it's really a fragility in the supply chain that we need to address to ensure that we're able to produce the capability for deterrence that's so important today. And I'm going to hand off over here to Ms. Giovanni Manzi, if I got your name correctly, hopefully close. She'll correct me if I'm wrong, from Rolls-Royce. And so I mentioned it's an industry collaboration. We need to find, is there a way for us to collaborate between the defense public sector units, the Indian private sector, and then major OEMs, where we look at our collective requirements and put a business case together to invest more in India to develop the aerospace raw material forging composites. That's a journey that we tried to kick off a few years ago, but I think we need to stay focused to try to take that forward. So I would say in closing, the different collaborations and initiatives may change names, but I think the interest is still the same. How can we find a win-win-win together where we can co-develop, or actually transfer technology, co-develop, co-produce in a way that meets India's requirements, but also can meet a global requirement, make in India for the globe. I think that's an opportunity that we all aspire to, because it will address the supply chain fragility, the supply chain resiliency that we strive for, and the self-reliance that, of course, India is striving for. So thank you.
Thank you, Mr. William. I would now like to request Ms. Joanna Manzi to talk about the global perspective on raw material supply chain.
I will put my glasses on. If it's not, I cannot see. So it's a great pleasure for me to see you all here and to have this opportunity to speak a little bit about our raw material for Rolls-Royce. I'm Giovanna Manzi, and all of you said pretty well my name, by the way, and I'm a Senior Vice President for Supply Chain Development in Aerospace Procurement at Rolls-Royce. I'm very honored, as I said, to represent Rolls-Royce in this event. It's a privilege to take a few moments and reflect about our relationship, Rolls-Royce and India, not only in raw material, but in the wider let's say, landscape. Our partnership with India is building on innovation, collaboration, and a shared vision of the future. Rolls-Royce has been forefront of pioneer technologies, driving advantages in travel, air travel, defense, but also in energy solutions, in new energy solutions. We look ahead. We're looking forward. We are committed to strengthen and expanding our partnership, particularly with the disrupting growth industry that we have currently in our space. India aviation is a market that is one of the fastest growing in the world, and you see an immense opportunity in this country for support this growth. We just announced yesterday that we have a huge intention to double our sourcing policies in India, and we are really moving forward. That's why we are. It was my first time. This is my first time in India, but we visit. I'm not coming only from the air show. We stay another week visiting suppliers, and they recognize the big capabilities and the capacity already in India. Few companies in the world can do. Only few companies in the world can do what Rolls-Royce do, and in our industry, there are high barriers of entrance. We recognize this. It's not easy to enter in aerospace. But as I said, we see this in India, and there is a big push forward in this sector. And they require deep expertise. It's technical expertise. It's not a sector that we can enter quickly. We need technology, advanced technology, but also long-term investment. This sector is not as quick as other sectors. We need long-term investment and really working together. That's why collaboration is so important. The key enabler for success is really to set. We are reshaping our global supply chain, and India have a bigger play to hold here. And India, for us, it's one of our biggest player. Our company will help accelerate the induction of new suppliers. We have a very successful stories in the last 12 months. Suppliers that is from in less than 24 months, building a completely plan and is already fair to a lot of components for us. That is, we really see the agility of the supply chain in India. We are building our global ecosystem in line with what is the Honour Minister of Defence, the Indian Minister of Defence, mentioned in his few weeks ago in UK, that we want to really to align our two countries and really work together in this. That is definitely is something that we recognize and we really work together. With a significant sourcing footprint, as I mentioned, we wanted to duplicate our presence in India. We are not growing civil aerospace, as Bill Blade says. It's not only the defense, but also the private sector that we are wanting to grow, and that you will see a big opportunity. And we are developing not only defense, not a civil, but also power system. We have the other areas of the business that we see a huge potential in India. Rolls-Royce has helped develop manufacturing capabilities, as I mentioned. There are suppliers already, that is our suppliers, that we are building together those capabilities in India, and is with a very high level of standard for quality and methodology. We have that is not it's building the quality of the currently. We have a strong joint ventures, 2 joint ventures currently in India, and we work with companies like Tata, Bharat Forge, HLL. We have this strong relationship, and we are building more, and we are bringing more players to work with us. When I says that we wanted to increase our presence in India, it's not only from simple components. We are working out much more complex components and also the vertical integration. That is, we go to our point. It's not only machining, but it's the raw material, and the vertical integration is key element for us to really building the full capacity in India to satisfy our demand. And that is really aligned with the country vision, no? That the make in India for the world. That is one we are really supporting this. Let's speak a little bit more about raw material itself. That is a conundrum, no? It's a challenge, but it's a big opportunity also, no? We can use the both pictures. One of the most critical areas for Rolls-Royce as of today, and I assuming that is for all other OEMs also, is the procurement of raw material. It's a highly constrained supply chain currently, and with in our markets need additional capacity. We need a new entrance. We need a new capacity and the new capabilities to really build up and to respect to support the demand that we have. The demand is increasing. The currently capacity is quite fixed, and we see that pressure in business continuity, In some cases, the cost, but also the availability of the material. It's something that we are seeing, and it's not only in Rolls-Royce. We are seeing in our company, that is our fly hours, is really recovered back to pre-COVID. That is it's a good news. That is our demand is really strong. But the raw material is not seeing the same ramp up, unfortunately. The capacity, it's not a return, the same input. And we are see that it's like extending our lead times, and it creates a lot of tension in our supply chain. That is increased cost, increase, as I mentioned, the business continuity. In Rolls-Royce, we are really focusing the security and long-term partnerships and the sourcing strategy to increase the capacity, but also the capability of our supply. We have a very small number of companies capable to do the materials that we use. That's titanium, it's nickel, it's the super alloys. We don't have that much, let's say, places to choose, and we need to increase this capability internally. We recognize, it's a big recognition that this sector is require high capital requirement, and there is one barrier of entry. We see this, and we need, but that's why the partnership is something that is Bill mentioned. We need to work probably between OEMs, between governments, but between also the different components of the supply chain. We are continuing our trajectory. We are growing. As we have, for example, from 2024 to 2025, we are seeing our increasing in terms of our internal demand for the new engines around between 15+%. That is a huge increase. And also, but we have also big demand in our MRO. That is the overhaul basis. That needs spare parts, and that it's a big increase also. It means that we are in the booming sector, and the additional capacity is really needed. We are continuing our trajectory to grow, and we are continuing to invest in our global supply chain, and it's important commodity areas like raw material. But also, we cannot really forget that we are harness opportunity in the sustainable aviation. That is equally important. We needed to guarantee that we have a sustainable sector. We not only get the capacity in any price, we need to think about. And in Rolls-Royce, we are deeply committed to the future of the sustainable aviation. Not only in the fuel, but also the footprint of the parts. That's why we are really play the vertical integration to minimize the footprint of the parts and to really have the right supply chain in India to satisfy our demand. Our engine has been successfully tested. In terms related to the sustainable aviation, our engines is something that we want to share, and that is very well known. That is, our engine is well developed and is tested with the sustainable fuel, aviation fuel. And we're really proud to declare that we have one of the most efficiency aero engine currently in the market, that is the trended XWB. The future looks like even more promising with the UltraFan, and it's an innovative step forward in the cleaner, more efficient air travel. I'm truly excited. It's my first time in India, but I see a lot of great opportunities here with this journey that we are building together. The relationship between Rolls-Royce and India has never been stronger, and it will be more stronger. And we are really eager to see our partnerships continue to flourish in the commitment decades. Together, I think together definitely we can drive innovation, strengthen our industries, and create much more sustainable future for this sector, and really winning together. Thank you.
Thank you, Ms. Joanna. I think you gave us a very powerful message that together we can create and innovate better. I would now like to request Mr. M.K. Gupta to hand over a token of appreciation to our distinguished speakers this morning. Shri Shishir Kumar Patra, Mr. William Blair, and Ms. Joanna Manzi.
My heart beats beating so
I'd like to request Shri Brigadier Munish Datta, Senior Member of PhD CCI, to hand over a token of appreciation to Mr. M.K. Gupta. Thank you. I'd like to request the dignitaries for a group picture on the dais, so please stay. I would also like to call upon Mr. Subramanya Shastri from HAL, Mr. Pulkit Mishra and Mr. Sachin Sharma from PhD CCI. Mr. Sanjay Chawla ji, I would request you to kindly join us on the dais, please. I'd now like to request Shri M.K. Gupta, sir, to propose the vote of thanks.
So again, good morning, ladies and gentlemen. As we come to the conclusion of this insightful and engaging session on capability enhancement in indigenous manufacturing of aerospace materials, it is my honor and privilege to extend a heartfelt vote of thanks on behalf of PhD Chamber of Commerce and Industry and HAL. First and foremost, I would like to express my deepest gratitude to our esteemed panelists for sharing their valuable insights and perspectives. Shri Shashir Kumar Patra ji, General Manager, for highlighting HAL's role in strengthening India's aerospace ecosystem. Mr. William Blair, Vice President and Regional Chief Executive, Asia, Lockheed Martin, for providing a global perspective on aerospace innovation and strategic collaborations. Ms. Joanna Manji, Senior Vice President, Supply Chain Development, Rolls-Royce, for her valuable inputs on strengthening supply chain networks and enhancing indigenous capabilities. Your insights have truly encouraged our understanding of capability enhancement in indigenous manufacturing of aerospace materials and have given us much to reflect upon as we move forward in the strengthening of India's self-reliance. I would also like to extend our deep appreciation to all the delegates, industry experts, and stakeholders who have joined us today. Your active participation and engagements have made this session truly meaningful. A special note of thanks to our organizing team at PhD and HAL, whose dedication and efforts have ensured the seamless execution of this important event. We are also deeply grateful to our partners for their valuable supports. Lockheed Martin, SASMOS, EY, Starwire. Your contributions have been a vital role in fostering innovation and advancing India's aerospace and defense capabilities. Before we conclude, I would like to remind everybody that we have next session coming up shortly, which promises to be equally engaging and insightful. I request you all to please stay here and continue to be a part of the discussion that will further contribute to our collective vision of Atmanirbhar Bharat in defense and aerospace. Thank you once all, and we look forward to your continued participation. Jai Hind.
Thank you, sir. Thank you, dignitaries. We have next set of presentations on indigenization of aerospace materials and CEMI-LAC certification. There are different speakers for this, and we will have the stage set in a minute. I'd like to invite our presenter, Shri D. Subramanya Shastri, Additional General Manager, Planning, HAL, Foundry and Forge Division, Bangalore, to talk about an overview of indigenization of aerospace materials and its Semi-lac certification. Sorry for that wrong pronunciation. It is semi-lac presentation. So over to you.
Good morning, everybody. Today's theme presentation, that is indigenous development of aerospace materials. I am D. Subramanya Shastri from AGM Planning from HAL Found and Food Division. HAL is the major user of aerospace materials. We use various international standards from German specification, French specification, American, etc. Similarly, other specifications like company specific MSRR, RRMS, Honeywell and Turbomeca. We use metallic materials in different forms. It may be the bar, it may be the rod, plates, sheets, etc. What is the need for indigenization? HAL Found and Food Division started its journey in indigenization in last few decades, 3 decades. Because HAL Found and Food Division supplies forgings and castings for the major DPSUs as well as other private partners. So, we are the pioneer in indigenization of aerospace materials. We started way back. Main focus on the indigenization comes from because subsequent to COVID, there is a government policies which enabled us go for further indigenization of materials. To strengthen India's self-reliance in the aerospace materials, for Make in India and Atmanirbhar Bharat, we started this activity of indigenization of aerospace materials. In this presentation, I cover mainly what are the different types of materials need to be indigenized, where does the demand come from, and what are the infrastructure required for the development of aerospace materials, and what is the certification requirement. HAL demand for aerospace materials in the next 5 years is about 50,000 metric tons. I cover most of this one is a metallic material because 70 to 80% of the aircraft materials are metallic material, even though other non-metallic materials also involved in the aircraft construction. In the metallic material, the mainly aluminium, steel is the major volume, and other titanium, nickel is about 10% each. Coming to aluminium, the major 60% is by aluminium copper alloys, 20% by aluminium zinc, and other alloys 606 aluminium magnesium zinc and aluminium magnesium about 5%. As per the Indian aluminium industry forecast summary, from 8,000 ton, it is going to double in next 20 years. It is going to become 16,000 metric tons. So for whoever is manufacturing aluminium products, there is a huge demand in HAL alone. Coming to titanium alloys, 80% of alpha beta alloys are being used, 10% near alpha alloys, 5% beta alloys, then remaining alpha and beta alloys is about 5%. Steel, major 50% is low alloy steels, then about 10% pH and merging steels, 30% high alloy steels, then remaining tool steels. Where does this demand come from in HL projects? Our major projects like HTT 40, 70 numbers is under progress. LUH lined up around 380 numbers, and ALH about 25 numbers every year. RUA and IAMRH under production, under development. LCA, Tejas, there is the two programs, 83 program already under progress and metal action is completed. Next lined up is 97 program, metal action already initiated. LCA Mark II is under development. Similarly, the engine programs, ADUR 871 and 811, and also TPE 331-5 engines. For all this, all the metallic materials are being indigenized. For the next 30 years, new projects are coming in. Overhauling projects will remain another 10 plus years. So there is going to rise the material demand for the new projects like LUH, HTT 40 and LCH. Increase in demand for steel and titanium because these materials are being replaced during the overhauling and repair. But normally in HAL, the requirement is in terms of batch volume is very less, 1 ton to 5 ton. That is a challenge we are going to discuss in the next panel discussion and subsequent presentation. What is the typical procedure so that whoever is involved in this type of activity, let us briefly go through what is the procedure of procurement procedure in HAL. We always tender in GEM portal, that is government marketplace, and also in the limited tender to the registered suppliers. Typical, what is the typical specification of indent? That is the material specification. I like to mention here about 300 specifications we are using in HAL, which was rationalized to the about 50 specification. Out of 50 specification, almost 50 to 16 specifications we are already fully indigenized. Another 10 plus specifications, grades, we are already tendered under production in different suppliers. That covers about 60 to 70% of the volume. And this one is, what is the supply condition? What is the length required? It ranges in 1 meter to 4 meter. And what is the tonnage in each requirement is 5 tons. And what are the certifications are required? This is the typical tendering process. After the tendering, the TEC will be conducted. Technically accepted L1 offer will get the PO, purchase order. Sometimes volume is more, we are tried distribution class also. Manufacturing firm produces the material, test, certified with the ORDQA certification and deliver the material along with the certificate. What are the documents required? Release note from DJQA, test certificates, COC, then on demand or already available type test or LOA along with the supply. This is a sample test certificate. Here, in the test certificate, the main components like supplier logo and address, purchaser address and PO details, specification compliance, OEM details, customer specifications, traceability and manufacturing process, chemical test results, mechanical properties, and what is the NDT carried out on the material, COC. For manufacturing of aerospace grade, what are the infrastructure required? For aluminum alloys, we'll start with the cast ingot. Typically, these cast ingots will be extruded, rolled into the plate sheets, subsequently forged. Mainly the melting furnaces, DC cast equipment, macro micro etching facility, homogenization furnaces, then UT test facility, turning or peeling, cutting facilities. Semi-extrusions will be used for the final extrusion rolled plates, sheets and forged. Here, once again, the billet preparation, cut to the sizes, extruded into the different forms. This is the very important to understand, one, how to select the material for the different applications. The most important is the extrusion ratio. For the forging stock, which is going to further process, there up to 240 dia, extrusion ratio 4 is required. Extrusion ratio 240 to 300 and 2.7. For machining stocks, for other divisions of HAL, they use directly the raw material into machine and to the final component. So that requires around 6 extrusion ratio. Rivets and fasteners about 8. Simple definition, the cross section of the input billet divided by cross section of the extruded billet. That is the extrusion ratio. What are the other facilities for titanium alloys? Is the typical, depending on the specification, we select double melt, triple melt, plasma arc melting plus VAR, electron beam melting and VAR, followed by thermal treatment, forging, machining, peeling, grinding and cutting. Then detailed testing, that includes the micro, macro, hot tensile, creep, stress rupture and fatigue and fracture toughness, depending on the qualification testing. Coming to steel and nickel, once again similar, depending on the specification, air melt plus VOD, air melt, VOD and ESR, vacuum melting followed by induction melting, vacuum arc melting, once again thermal treatment, billet preparation, testing, qualification testing, etc. What are the certifications required? These are the certifications required by the organization. AS 9100 accreditation, approval from the DGAQA inspection coverage, SEMILAC approval. All testing facilities requires the NABL accreditation. Suppose if you do not have accreditation, you can go to some other NABL lab also. LOA, letter of acceptance from SEMILAC, release note approved by DGAQA, test certificate, COC, material identification, stamping on the bars, forged bars. We strongly believe indigenization we started, recently we strongly believe and will tell local to local. What do you mean by local to local? It is nothing but local. Manufacturing of raw material is from the local Indian industry, Indian mill. For that, what are the input materials are required also from the Indian firms. These raw material produced in India will be used by Indian industry, mainly DPSUs, and that will be machined and finally assembled into the aircraft. So complete local. That is with that mantra, we HAL we are going for fully indigenization of almost all our major programs. However, there is a concerns, issues, challenges in making indigenous development of aerospace materials. In the next panel discussion, we will discuss what are the issues, what are the concerns by the user, by the manufacturer and certification agency. We will have the detailed discussions so that we can go further, strengthens India's self-reliance in future. Thank you.
Thank you, sir. That was indeed an engaging session. I would now like to call upon Mrs. C.S. Bhuvaneshwari, scientist and regional director, FNF, Airworthiness Certification of Non-Metallic RCMA, to talk about airworthiness and certification of airborne materials.
Good morning to everyone. I'm Bhuvaneshwari, Regional Director of Foundry and Forge. So today I'll be talking about airworthiness and certification of airborne materials. If there are new vendors here, I'll be talking about fitness to fly and airborne materials, and this is only for the military aircrafts. So my presentation, I'll be covering what is IMAP 2023, which is the certification guidelines and policy. Next will be material certified, that is the spectrum of materials we are handling currently in RCMA FNF. And the compendiums we have released from CEMILAC. So what is the role of certification here? So our main role is, as always we insist, it is design adequacy as well as the test adequacy. So what do we mean by design adequacy in the place of airborne materials? It is the process design adequacy. So in which we require the user requirements, operational requirements and maintenance requirements, life cycle support and safety. This freezes the design. Then comes the test adequacy. Here we have to collect the test requirements from the users, basically end use application. So that is the main role. Based on that, we have to make a test matrix, that is also called test schedule, which is very powerful or very famous word we always call test schedule, qualification test schedule. And compliance to standards and specification, how we make the test schedule basically, based on some international specification or user requirements and end use requirements. Then approval of test rigs. So this is the design adequacy and test adequacy. So if we take a certification life cycle, so these are the major points, that is conception, design and development, testing, evaluation, service induction, repair and maintenance, upgrade, and then comes the retirement. So this becomes the two phases, that is design and development and in-service phase. So here comes the certification. Any major oversight in this process, we may have to prematurely withdraw the certification or the system or subsystem or the components or the material, or there may be a issue in the life extension process. So now I'll be covering on speaking only about the certification of airborne materials. That is the topic given to me, and that is where I'm working. So what it means, when we certify a material, we are also making the process freezing, like a batch to batch consistency should be there. And when it means the product is type approved, it means the material, the basic bill of materials, the process, the test requirements, all are frozen, the plant facilities, all are frozen into a document called process control document. So we have a DDP mass procedure that is called IMAP 2023. So we have three different categories of this policies and guidelines. One is called framework, that is IMAP 2023. Then comes different chapters which covers the IMTAR. Then comes the manuals. For certification of airborne materials, we have a chapter called subpart C3. Then for indigenous substitution, we have a subpart called subpart K. So for all these things, for the guidance, we also have the manuals, which is forms and manuals, level 3 document. All these documents, I would like to proudly say that these are available in the open internet in the CEMILAC website. So I would request everyone to please go through the documents and relevant support to their indigenization. So aero material, how we classify here, as Shastri sir already explained about the materials what we are indigenizing along with HL, Foundry and Forge, I would like to tell here, my RCMA also deals with non-metallic materials and fuel oil lubricants, pre-preg certification, that is composite, and we are also dealing with stealth materials. So here it covers in the non-metallic side polymer matrix composites, even fiber also we have indigenized, fabrics we have certified. Then in metallic materials it covers alloys, metal matrix composites that is used for brake pads, forgings, castings and 3D printing. Notwithstanding to that, we are also certifying the consumables, aviation turbine fuel, aircraft lubricants, paints, coatings. Here I would like to say that in ATF aviation turbine fuel, all over India, whatever the refineries they are producing the ATF, we are certifying that. So Suppart C3, I would like proudly say that which is made with the, it is not only the partner of this Suppart C3 is CEMILAC. This Suppart C3 drafted along with HAL, F&F, many private industries. So they are all partner to this Suppart C3, which is a simple, concise and unified regulatory approach for the grant of certification for the aero materials. So what this Suppart C3 I have been talking about, what it contains. Basically there are 3 subparts. So one is, if it is a ab initio material, how the certification should go through. Then if the material is under licensed production, so what is the procedure? Third comes the bought out item. So there are 3 sub classifications in this Suppart C3. So based on that, a well-defined procedure is laid down in this Suppart. So any vendor or any newcomer to this industry, they can appreciate it is a self-explanatory. So I'll be now presenting the procedure, how to, this Suppart C3, this flow chart, we can take it as a ready reckoner. So whenever a main contractor approach for the certification, what he has to bring with him. So first document is a process document, that is process control document we call it. Then comes the test schedule. Next is the ACP, that is nothing but airworthiness certification plan. This may be a new word, but earlier we used to call this as a route to certification. So then comes the technical data, if anything is there. Then part criticality. You may be thinking I am just speaking about the materials. What is this part? This part criticality means anyway ultimately the material will be converted to some parts, components. So whether the component is critical or non-critical, so we have to classify that through the SSA analysis, system safety analysis. Based on that, we'll be classifying that component as a critical or non-critical. That is also called flight critical, mission critical or non-critical. So once these documents are submitted to Technical Airworthiness Agency, we conduct a local type certification committee meeting that is headed by RD RCMA as a chairman. Then main contractor, user, DGAQA and all experts will be there. So based on the LTCC meeting, we'll be approving the process document, test schedule and the airworthiness certification plan. Then comes the development and testing trials. We have to do it. So once the compliance report of development and testing trials, then we'll be, excuse me. These 3 documents will be submitted to the CEMILAC. So based on this compliance report, we'll be giving the provisional clearance. In college also you might have heard a provisional clearance, certificate issued before the final certificate of LOA, that is a letter of approval. So if there is any long cycle testing is pending, that time also we give provisional clearance. This is only applicable to do the functional trials. This is not applicable to fit into the aircraft and do the regular production. So once this PC is given, they can make the component out of this material and it can undergo a functional or endurance trials. Once the trial is done and we get the satisfactory performance feedback, we'll be giving a letter of approval for 10 years. If it is a non-critical item, then it will be cleared in LTCC for lifetime. Then comes the acceptance test plan for the production. That will be approved by DGA QA. Then only it can go to the bulk production. So this is the brief procedure as per subpart C3. So what is the role of Semilac and DGA QA? I'll be explaining here. Together we call this agency as Technical Airworthiness Authority. So Semilac here responsible for the certification and DGA QA and Competent Inspection Authority. Here we would like to say that the inspection authority which is relevant to the Air Force and Navy, we call it as Competent Inspection Authority for their organization. So they'll be responsible for design and development as well as production, and also they'll be involved in the maintenance activities. So who can approach this two organization for the certification? They are public sector, private sector, or any R&D organizations of government, semi-government or private industries. So these industries or public private institutions will be called as design and development organization or the main contractor. So I have been talking about route to certification or airworthiness certification plan. What it has to contain, what it has to include is description of the item for which the certification is intended for, then applicable aerospace material standards, then comes the qualification test schedules, process control document, drawing if it applicable, then the criticality classification of the parts, and the major milestones and material identification or traceability. So as there is a paucity of time, I'll not be able to cover all the details into the qualification matrix of these materials. So these are the spectrum of materials we are handling. Currently, we are into this cutting edge technology like additive manufacturing and indigenization of composite prepregs, mill forms, elastomer aircraft paint, coatings and powder metallurgy brake pads, castings, forgings, ring rollings. So these are the spectrum of materials. We are also handling the stealth materials, so that I have not added here. So these are some of the compendiums we have released from Semilac. So nearly 6 compendiums are there. Some of the compendiums are available in our Semilac website. You can refer to that. Thanks a lot. Thanks to the organizing committee, they have given me this opportunity. And I would like to say that we have indigenized more than 15 workhorse alloys under the chairmanship of our Director Materials, Dr. Kale sir, and our visionary GM HL FNF, Dr. Anil sir. Thanks a lot, sir.
Thank you, ma'am, for a brief yet very elaborate presentation on the process of certification. I would now like to call upon Shri Isaki Muttu, Additional General Manager of Design, HAL, to talk about advanced materials for aero engine applications.
Yeah, very good morning all. Yeah, this advanced, I will be speaking on advanced materials for aero engine applications. So this doc is prepared by me and my colleague Hardik Rai, Senior Manager Design. So my talk will be with respect to full Indian perspective and with respect to aero engine design aspects. The presentation contents. So it will have gas turbine materials introduction, then engine material distribution and specific strength of the materials. We have the cold end section in engine and we have the hot end section. The cold end sections are covered with magnesium alloys, titanium alloys, aluminum alloys and metal matrix composites. And hot end section we use the super alloys, nickel alloys and single crystal turbine blades and various specs I will be covering. The CM-SX4 Udimate 720, CM247LC, IN 738 and ceramic matrix composites on the engine applications. The modern engines mainly it demands the less weight and high thrust. So that when it demands high thrust and less weight, it falls on applying the extra loads with higher temperature and pressures. To take care of the higher temperature and pressures, the responsibility will go to the materials. So we expect high strength materials which will capable of operating at very high temperatures. And the structural design, it demands with creep and other properties. So the advanced materials, it is catering to achieve the improved engine capacity, efficiency, reliability and life. And it also contribute to the less fuel consumption. Achieving these object leads to high temperature and inlet gases, enhanced pressures. So the final role played is the advanced materials, which plays the very important role in the gas turbine component design. These are the schematic of the engine. So the green color is the titanium alloys, the blues are steel alloys, the red color indicates the nickel base alloys which are used in the gas turbine components. The pink is the magnesium and aluminum alloys. So if we see the metal contribution to the engines, so up to 200 degrees centigrade we go for the aluminum and magnesium alloys. And the next part, the compressor section, we go for the either titanium or steel alloys up to 600. And combustion chamber and the turbines, we go for the nickel base alloys. So the four materials contribute the whole design aspects. That structural integrity part basically determines what kind of material it requires. So there are three things, any structural design if we take, it is load, geometry and material. So when the load and geometry are optimized, the material plays the important role to have which material we have to go for the design. So if you see the material characterization, so up to 200 degree, whatever I explained, so that aluminum alloys, steel and titanium are equally withstanding up to 450-500 degrees centigrade. And super alloys beyond 700 degrees it is used. The titanium is having the very high specific strength, that is strength to density ratio. It is having the very good specific strength. These are the cold section material requirement when we take into engine components. So the gearbox, gears, casings, impeller and all cold section. So it requires high strength, high stiffness, low weight. The materials are okay, I explained the titanium, aluminum, magnesium, composites and MMC, metal matrix composites are the new trend, it is used on the gas turbine components. So if you go into the cold section gearbox components, the magnesium alloys, these are the alloys used in the gas turbine components. So its main application is the castings, engine casings, instrument housings, brackets, mountings, forgings. And the advantage is it is the lightest, very light material and temperature capability is up to 180 degrees centigrade and it has a low modulus elasticity. The titanium alloy, it is having the high strength to weight ratio, very high strength. And mainly, we use the TA6L4V or TA662, 6242, 6246. Within titanium alloy itself, there is a high strength titanium alloys, and there is a alloy which will have the temperature capability, creep characteristics. So with respect to this aspect, these are the materials we propose to indigenous. We enormously use 6L4V, but we also should focus on indigenizing TI662, 6242 and 6246, which are high demand in the new engine design. So these are two aspects, TI662 and TI6246, its advantages, and the 6L4 is more of the high strength alloy which has the more high fatigue life, and the 6246 the compensate which will have the both strength as well as the high temperature properties. So the aluminum alloys, as I told, it is having the application up to 200, 300 at less density. And major alloys what we use in the gas turbine is the AU2GN, that is 2618, which is used in the more of the rotating parts where it needs the strength as well as the fatigue characteristics. And the next one is the AU4G1 2024 and the cast alloy A7G06 aluminum alloy. These are the material found in gas turbine application. And the metal matrix composite, these are things it is used in the other OEM engines. So the metal matrix composite plays a very vital role to design the engine. It reduces more than 60-70% weight reduction. So earlier we got the blade disc all separately. Then we came up to blisk, that is a bladed disc. And now the concept is with the metal matrix composites, it is a bladed ring, bling. So to reduce the weight, when we reduce 30% or 40% weight, the thrust all it will go up, thrust to weight ratio will go up very high. And hot section materials, the hot section it has to withstand metal temperature. I am talking about 1150 degrees centigrade. Some materials are there, it has to withstand up to 1150 degrees centigrade, where the TET will be 30% more. So in general, metal to this 30-40%. So conventional material, it suffer creep phenomena. So it should have the high strength, elevated temperatures, fatigue, creep and rupture characteristics. So nickel advantages, okay, the material development, if we see over the period, it has gone from the conventional castings, then DS, equiaxed, and single crystal. In single crystal also we have the various generations. It gone up to 8th generation. So the single crystal alloy is the major alloy in demand. We have indigenized, okay, I will come up in the next. We have indigenized on our shaft engine, HTSC. This is the HTSC blade. We have indigenized through DMRL, this single crystal blade, where we imported the material CMSX4 from foreign OEM. So it requires a temperature TET of more than 1340 degrees centigrade. And the TET is achieved in three ways, either blade cooling or improved casting process through the advanced methods, single crystal, or improved TBC coatings. So these all three technology plays the role to increase the TET. And turbine blades are, and it can be casted through either equiaxed or directional solidification or single crystal. The single crystal blades have a superior creep strength, thermal fatigue resistance, and corrosion resistance. So and it has the properties more than 6-7 times compared to the equiaxed castings. So these are the generation of the single crystal alloy. If we take first generation, it is having the 0 rhenium. The second generation, it is up to second and third 3% rhenium. Third, it gone to 6% rhenium. Fourth, it is 5 to 6 rhenium and ruthenium is added. And fifth generation, 6% rhenium and ruthenium. If we go to the next one, sixth, it is added with cobalt and tantalum. So every generation is adding some 20-30 degree temperature benefit. So when we say it is around 50 degree benefit, either the weight we can bring down the weight 20-30%, or you can increase the thrust almost 1.5 times. So the strength to weight ratio will go up. So this is a single crystal plate we have indigenized through DMRL. The material we use CMSX4 alloy. So the next important thing is the isothermal forging. Edimet 720. So this is the one of the isothermal forging. We got it done through foreign OEM for our indigenous project. So it requires hard die. This Edimet 720 cannot be forged in the conventional methods. So either it requires hard die or isothermal conditions. So to increase the your properties, to have the better grain flow. So when you compare with Udimet 720 and 709, it has the more than 30% extra either tensile or ultimate strength, and it can withstand up to 800 degrees centigrade. So it is having a very high strength and comparatively density also less with respect to 709. The next alloy is the CM247LC. The CM247LC also we have used extensively on our engines, more of all nozzle guide vanes and turbine rotors, all this one. So this already got indigenized in Midani, so as a Superneat 247 alloy. So this also we are using on more of our engine applications. The next requirement is the iron 738. So this also used on the turbines and NGVs. So, but this material we are using as a 3D printed alloy. So, more of the alloy development will be very helpful to develop all our engine components. The next, our focus should be the ceramic matrix composites. So, it has the very less density to reduce the component weight, and it has the all thermal creep properties. The CMC parts can operate at a higher temperature. It has the reduced, it needs less cooling, where other materials requires the cooling, this one. So the ceramic matrix composite requires less cooling so that your engine performance will improve. So that aspect, it will have the more of the bleed air requirement will reduce when we use the ceramic matrix composites. So this is the one of the development we have to focus in future. In summary, just I want to conclude, there are the 4 basic things. In the nickel alloy, we will be happy to it get developed CM SX4, SX4 plus or SX10 and 738 and some more alloys, and Udimet 720. And in titanium, apart from what we use regularly, TA6L4 with TA8DV and other alloys, that is the normal alloys. These two, TI662 and 6242 and 6246, one more, I missed it. So those development will help in engine development work, it will be more useful. And aluminum alloys, the AU2GN, A7G06, that is a cast alloy, and AU4G1, 2024, some more 2014. With respect to bar stock, the engine application, it will be more useful. And steel alloys, 15.5 pH and 17.4 pH, some of the alloys are already indigenized. And S106, 30CD12, DMRL has developed, Midani has developed the equivalent material BS S132 for S106. And other is the AMS 5628. So these are the alloys that we can focus for our, to help the engine development program. Thank you.
Thank you, sir. We'll now move on to the crux of today's program, the power-packed panel discussion. But before that, I'd request all the audience to kindly stand up for a quick mind-cleansing and attention activation activity. Can I request all the delegates and audience to please stand up? A very simple thing, it's just clap, snap, and tap. When I say clap, you clap. When I say snap, you snap. When I say tap, you just stomp your feet. Okay, let's just try. Clap, snap, tap, clap, snap, tap, 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 clap, snap, snap, clap, snap, clap, clap, snap, snap, clap, clap. Wonderful. Thank you so much. Keep clapping and please put your hands together to welcome our panelists onto the dais. It's just so nice to see that bright smile on all your faces. Sometimes we just get so serious thinking like the entire world, the pressure of the entire world is on our head, but smile, yaar. Come on, it's just nice. Feels good. We'll just give a few minutes for the team to set up the dais and then we'll have the panelists on the dais. The next session is roadmap for self-reliance in aerospace materials. The discussion on how indigenization of aerospace materials can be accelerated by Indian DPSUs and large Indian defense companies, thereby ensuring business for Indian MSMEs under Make in India. The issues, challenges, and way forward. All of this is going to be discussed in our next session, and we have some industry experts and stalwarts who will be joining us for the session in very bit. Okay, while they set up, let's do a quick show of hands. How many of you are attending Aero India for the first time? Any newbies in the hall? Wow, can we have a big round of applause to welcome the gentleman? He's here for the first time. How many of you have attended this twice before? Twice. Okay, we have somebody who's attended twice. All right. How many of you have attended more than 5 times? More than 5 times. Okay. A big round of applause, more than 5 times. Somebody who's attended for all, like who's been a part of all the editions. All the editions. We have somebody, so can we request you to kindly stand up? I mean, I'm sure everybody would like to see. So we have 2 of them who've attended all the editions of Aero India. A big round of applause to them. Such a pleasure to have you with us. On that note, I would like to request the panelists onto the dais. This session will be chaired by Shri Sanjay Chawla, Director General, DGAQA, Ministry of Defence, Government of India. So can we have you on the dais, please? The session will be moderated by Shri Balpreet Singh, Manager, Aerospace and Defence, Ernst & Young LLP. The panelists now, we have Shri A.K. Sharma, General Manager, Mishra Dhatu Nigam Limited, MIDHANI, Medani. We have Shri V.N. Anil Kumar, General Manager, Foundry and Forge Division, HAL, Bangalore. Dr. Shirish apologies. We have Dr. Shirish Kale, Scientist, Semilac. Can we have you on dais, sir? We also have Shri Rohit Deb Barma, General Manager, a unit of Yantra India Limited, Nagpur. We also have Sri Chandrasekhar HD from Founder Managing Director, Sasmos HET Technologies Limited, joining us on the dais. We have Dr. Kishora Shetty, Associate Technical Fellow, Global Technology Leader, Materials and Manufacturing, Boeing, India. Sri Shailesh Prasad, General Manager, Export-Import Bank of India. And we also request Sri Subhash Chandra, former Secretary, Defence Production, to kindly join us onto the dais. With a big round of applause, can we welcome all the panelists on the dais? And I would like to request Sri M.K. Gupta to hand over a token of memento to all our panelists. Can we have the mementos, please? To Shri Sanjay Chawla, Director General. So thank you so much for joining us this morning. Shri Balpreet Singh. Thank you, sir. I would now like to hand it over to the moderator, Shri Balpreet Singh, for an exciting, interesting, insightful deliberations. Sir, over to you.
Thank you very much, and very good afternoon to everyone, and thank you for being here. We have an exciting panel over here to discuss the requirements and a roadmap for self-reliance in aerospace materials. And to start, I would just like to start with one statement, that there is no Atmanirbharta or self-reliance possible without indigenization of strategic materials that are used in both aerospace and defense. So we have an exciting panel with us. I would request the chair, Sri Chawla, to start the session and give the...
Yeah, very good afternoon to all. At the very outset, I congratulate the PSD Chambers of Commerce, led by Mr. Gupta, and HAL, Mr. Anil Kumar, organizing this important seminar on indigenization of aerospace materials, which is the need of the hour. We had carried out a small study recently, and that time we could accumulate that about 14,000 crores of materials we are importing, and the pace with which it is growing probably was likely to have around 35,000 crores in the next 5 years or so. So it's a good business for all of us. And in fact, I was chairing one of the committee on certification towards ease of doing business, to start the process on a faster rate and see that we are self-sufficient in this area. And in that sense, while taking all the stakeholders into picture, we could give 4 or 5 recommendations. And I'm very happy to state that those recommendations were, implemented very fast, and many of the industries in private sector are taking benefit of these. So I'll just list small 5 numbers which we gave. One was that the major, bottleneck was the material development. There was a need for a having a supply order first for the technical airworthiness authorities to be part of the development and certification. So that requirement was waived off. Now any industry can develop material ab initio without having any firm order either from DRDO or HAL or services, and they can take both the technical airworthiness authorities comprising SEMILEC and DGAQA for providing coverage. So I'm very happy, a lot of industries are taking benefit of it. Number of alloys are being developed as a parallel activity. And once this development is done, you can save a lot of time, which may take average of 1 year for a full certification for a aviation grade military material. So this is one area where industries are taking benefit. The other thing was the timelines have been fixed for issuing of the QTP and the ATP by both SEMILEC and DGAQA, which is 3 months and 1 month. So that, the government regulatory bodies also are working in the time which, industry expects. Another thing was, the most of the time, our furnace capacities and the full batch taking, it is not economically viable because there will be risk involved. You have to define, you have to freeze the process. For that, number of iterations will be required. And in that sense, we allowed that you can do on a lab scale model, on a small model, and freeze the process later on. And then the production, actual production can be scaled up. So this feature has been added for the material development also. Next one is for the sake of giving, as we are getting the foreign materials on COC basis. So that option was also exercised that the end users or the main contractors can get the material on the COC basis as we are getting the imported material. So this feature was also added. And for non-critical materials, initially we have given that instead of having the 3 batch for certification, so with 1 batch itself the certification can be given. To have the consistency generally for the flight critical materials, 3 batches before we freeze the process. So that we have started for non-critical. In the next step we can go for mission critical, and then of course it will be in the flight critical mode. So one area, in the morning hours I was, able to see all the presentations and all. RCMA also gave a lot of things. I think one area I feel both the industry partners are there, a lot of designers I am seeing, even some foreign firms, OEMs are there. What I feel the major thing which is affecting the material development, particularly aerospace material, the MOQ requirements are quite high, and economic viability to process small materials is a major issue. So in that sense, what I feel that the rationalization and standardization of material is the need of the hour. A lot of work has been done. Further, I feel our designers, whether they are in HAL or in DRDO, they should look for taking materials which are already developed rather than always taking new materials. I have seen my experience that number of designers, they will be having their own, liking for a particular materials. And instead of that, with the small quantities, it will not be in the long run. We need that all designers, they should see that whatever indigenous materials are available, we should try to use those materials. They can be rationalized so that we can make as a bunching of the material category. As also our license projects, I request, whether licensors like Rolls-Royce or Lockheed Martin, they can look for whatever materials as part of technology or license production they have given. I mean, they can substitute with the alternate indigenous materials. So their main contractors also can take up with their license firms, which can speed up the indigenization efforts and make the thing economically viable. Thank you, and I think we'll be available actively. And now we can give to the questions which are welcome from all the participants. Thank you.
Thank you, sir. And very valid points that you set out. So I would like to start with Mr. Sharma from Midhani. Sir, as you're aware that India is still dependent on imports of various types of materials, and from aerospace grade to other types of grades. So what are the most critical aerospace materials that still need to be indigenized, and how is Midhani working towards indigenization of these materials?
Hello. Hello. Good afternoon to all. So Midhani is almost 51 years completing our journey. The Midhani was conceptualized to develop alloys which are the import substitutes. So we work with the indigenization spirit from the day one what we are working. Almost more than 200 grades of alloys we indigenized, and we are currently we are with the help of HAL. A lot of grades are we also indigenizing. Let it be nickel alloys, titanium alloys, As you, what you are asking is that most challenging alloys to be indigenized. I say that a lot of West OEMs, they indigenize their own materials. So like Inconel 718. So like Pratt & Whitney indigenize 718 plus, 718 plus plus, which having more height service temperatures. Such type of grades we have to we are looking for indigenization. We are looking for a West alloy indigenization. And similarly like GE OEMs like Rene series. We recently developed the indigenized Rene 41 grade of alloy for engine manufacturing. So Midhani is capable of indigenizing any nickel alloy given to us. Only thing is that we look for actually the challenge, major challenge will be the volume and the pricing. So what we are getting requirements is not a bulk requirements, is initially small quantities MOQs we are getting. So we are not able to convert into indigenization because as a certifications calls for 3 batches to be, as chair said, 3 batches to be made. So we have to have that requirement of 3 batches so that we can process and certification can be done. Then it's called total indigenization. So there is a facility is been given, like 1 batch is taken, provisional clearance is given. With that way we are working with certification agencies. And another is requirement is input raw materials. Like for making incalloys, we require chromium, other than nickel, chromium, cobalt, tungsten, moly, so many other grades of materials required. So at this forum, I say that inverted duty structure. As you all know, that nickel alloys, when we import as a finished product, you get a 0 duty. When we buy this raw material, we pay duty on it. So domestic manufacturer doesn't get advantage in indigenizing manufacturing. So at this forum, I propose to have a policies, inverted duty structures or some duties to be structured in such a way that domestic manufacturer get advantage over import supplies. Thank you.
Right, sir. Thank you so much. Sir, moving to Mr. Kale, as you're aware that certification remains a bottleneck for new materials that are being used in aerospace and defense manufacturing. So as Semila, can you please highlight what are the key challenges that Indian companies face in terms of certification of new materials, and what are you doing to help MSMEs and small companies that are getting into manufacturing ecosystem of the materials?
Yeah, good morning all of you. And the question rightly posed, what are the bottlenecks? Definitely there are things in each of the processes. There are certain things we need to take care. And as you are aware, any certification needs and a qualification requires the evaluation of certain properties. And that needs certain time to do the qualification requirements, for which the design, the qualification testing, and what are the requirements. What I mean, what are the requirements, the end-use requirements, the requirements comes out of that, what are the evaluations we need to do. So these are the things we need to perform. But the new materials, he posed the question. At present, most of the industries, we have got the facilities, melting facilities, maybe 3 tons, 4 tons, 5 tons. When we look at, as rightly pointed out by DG Chawla sir, that our quantity, MOQ is very less. And when we start with that, we should have, when we do the new material development at the R&D, we should have a smaller capacity furnaces, 0.5 tons to 1 ton. So that, and the another requirement is of 3 batches, what just now our Midhani friend has mentioned. So these requirements, you cannot produce a material which is for the aircraft in a 1 batch if it is that design, that is the process control document, is not matured enough to give the repeatability and reproducibility of that product. So this is one bottleneck which I see is the quantity requirement for which the smaller capacity furnaces are needed, which many of the cases are not there, even for the conventional materials also. So this is one of the things which we have brought out in one of the committee which ASDP has brought out. I think Chawla Sahab was also there. This was one of the requirement we gave there. To come out this, another bottleneck, I'll talk first what are the things which are coming for the 3 batches. Even though is there for the first batch, when we do, we freeze the requirements, we make the schedule, we do that first batch, we see that what the process is followed is frozen to the requirements given. To that, we give a certification, one provisional clearance, and we give a time to them, almost 2 years, to give, to make a component or the end use requirements to make a component, make a fabrication and get the feedback of that. Parallelly, 2 batches can be produced and finally the letter of acceptance can be given. These are the typical things. Even though these particular things we have brought out in our, there was no certification approach earlier, it was there, it was brought out in IMAP, which will be released today by RM at 2 o'clock here. So this particular thing we have brought subsection C3 where the staircase approach has been mentioned, which is one of the part of that which I talked earlier. And that can make industries a very handy experience, handy things to get first batch, get the things done, start getting the components fabrication, get the feedback, do the parallelly this batch also, if your feedback comes, that can go into the thing. Only the life of the component or life of the thing that can be done throughout the process once the part is in, that can be also done by the staircase approach or maybe by the testing also. So these are the things which I feel that not as a basically a certification bottleneck, from all the certification stakeholders, we need to address this point. And one point again for the industry, because they come approach us when because of RFP or MOQ, RFQ is issued by the designers and all, they say Semilac certification is required in their tender, and they get that tender, and within 1 month or 2 months you can't do if the material is not indigenized. If it is already indigenized certified, that can be used. So my request to the designer is that when they produce this, that RFP, that RFQ have certain requirements for which the template have been designed by Semilac, that as a part of certification kit also is being released today by RM in the afternoon. So that will get handy to the industries to not put lot of time to what are the things I need to give to Semilac and all those things. So that handy materials, handy templates have been now designed, and I think the IMAP and IMTR documents are there which can guide them. Even there are certain videos for the how to go for the certifications. These are the things are there. I think these are the minimum things we need to do at present to make the industry more participative in the defense area.
Thank you, sir. That's very, very informative. I would like to move to Shri Anil Kumar. Sir, as you're aware that HAL is one of the largest consumers of aerospace materials. And what are some of the challenges, or if I say some of the biggest challenges that HAL faces in terms of usage of indigenous materials? And how is HAL enhancing sourcing of these materials from Indian companies? So if you could just throw some light on that.
Good afternoon, and thank you for the question. As you all know, HAL works for varieties of global partners across the continents. So we didn't do our own product design probably till recently, till LCA or LH. So what we used to do, we used to try to replace those specifications in the country. There was no need in those days. Many, like Midani, organized like Midani used to develop it, DRDO Midani used to develop it, but the question used to be that they always used to be L5, L6 and this week thing. And a lot of wonderful things have happened recently for the benefit of India. One is that Government of India's intent to make in India and make for the world so serious. They made it a lot of checks and balances that before we buy. That thing happened, and apart from that, the recent 2 wars has made the global supply chain, and this COVID also has thrown this entire supply chain in aerospace material into a toss. Even the Western mills, they don't have operators. Some of the European fellows, they don't have power. So what used to be a free flow 3 months from the date of order, now it's going 80 months, 60 months. Forget about for us. Even the global OEMs are not getting. Now the whole thing is turned. suddenly there's a love for Indian mills, not only by HAL, every Indian industry. Forget me, because HAL Foundry and Forge, you may not be knowing, we make almost 100 crores of exports every year. We are going much beyond that. Material used to come on a nomination basis from the foreign OEMs. Today they're coming to us. In fact, last time I had to go to Midani with one of the major OEM to supply 708 for them because they had placed an order. So HAL Foundry and Forge has gone beyond sourcing from foreign source. We understand materials. What we have done is we have asked not only our designers here, all the OEM designers, we asked them to standardize on AMS specification rather than go for company specifications. It can be made by anyone. There's no license issues, number one. And number two, the very big projects of HAL, you all know LCA and ALH helicopters coming in a big way. HAL is going to buy these things. Already my friends sitting here are evidence. Most of the firms sitting here in the last 3 years, most of the Indian mills, whether it's steel or nickel or titanium or whatever alloys we saw, most of them we have all indigenized thanks to a coordinated efforts, RCMA and DJQA and HAL. Almost Mr. Shastri very clearly brought, Madam Bhuvneshwari, Dr. Bhuvneshwari brought it very clearly. We are all working together. We used to, once upon a time, we used to write, you must have a type approval to supply. No, we are no longer liking that. At the time of supply, you can have type approval. Not only that, we are asking, we are hand-holding all of them. I think many people, they know it. All three organizations are hand-holding. See, in aerospace material is not something great. The Indian mills who have come, they are much, much better than the mills what I've seen in Russia or Western countries. Very beautiful advantage you have compared to the 100 years, 60 years mills they have. What is a scare? The fear is the quality system, the documentation, and alignment to aerospace. When your raw material is not good, a Western fellow will delay you. No, I have not got the values, so this batch fails. He is honest enough to tell. Are we to that level? The Indian mills are to that level. So Midani, to a very large extent, they have the maturity there. So when they come to that maturity level, it's good, it's going to happen. I am assuring, I am sure in the last 2 years, as Mr. Shastri brought it out very clearly, HAL, Semilac and DJQA together brought more than 20, 30 specifications. And more democratic development has happened. Many of the Indian mills are now qualified. It's beyond, Midanis are much more relieved of making steels. They're going probably nickel and titanium in a big way. So it's going to make us, HAL and many of the defense expenditure going up. I'm very sure, in fact, we are sitting in their mills now, ask us to give more. That should give a big confidence to all of them, sir. Thank you very much.
Thank you, sir. Thank you for that. Moving to the industry, so Dr. Kishore, as you're aware, and as everybody is also aware, that Boeing has been sourcing a lot of materials from India. But the question is, based on if there are, what are the gaps that Boeing sees in the Indian industry, and what is Boeing doing as per their point of view to bring about integration of Indian-made materials into your supply chain? Thank you.
First of all, thanks for the opportunity. I had the privilege to be first decade working with the DRDO. I was part of DRDO, Semilac. And then last 1.5 decades, I'm with both commercial and means we call civil aviation and defense. Coming to sourcing, Boeing is stepping up to source Indian content to the Boeing planes, okay, be it defense or commercial. So as of now, we stand at around 1.5 billion, and we are going to grow to 2 billion soon. And what we are doing is, our policies, we don't directly buy, okay. So when we go to anybody, they immediately ask us what is your order quantity, okay. So we will not able to do that, but what we are indirectly doing is, we are telling our tier 1, tier 2 suppliers to buy from Indian companies, okay. So that's how this 1.5 billion sourcing is going to happen and growing to 2 billion, okay. We started developing some steel mills, aluminum mills, and also castings and forging suppliers. And what we are trying to do them is develop and get it qualified from us, Boeing as a OEM, and then supply to Indian tier 1, tier 2 companies. Okay, so that's the one hand-holding we are doing now. And couple of suggestions on the MOQs, correct? So, what I suggest, no, Indian companies, when they start at 3 melts, okay, minimum 3 melts for required for qualification. What you try to do is, you try to do it for like, if HL needs, they will try to make 3 melts for only HL. What I see a opportunity here is, don't only go with HAL, try to come to Boeing or Airbus or somebody else, okay? If they need the same material, you can not even 3 melts, you can make 10 melts, correct? So, it's like both commercial and defense you start tying up, no? It is a huge opportunity, okay? So, what you need is for a defense, maybe what commercial needs maybe 10 times, 20 times of that, okay? So, if you try to collaborate and see what else is needed in the, for the same alloy, so that is the one opportunity lies. And second thing, why so many materials, correct? So, today you have around 2000 different alloys. If you take only metals, that's where the aerospace, correct? So, for the materials R&D from maybe last century or so, why so many materials and process developed is only because of aerospace. No other industry demands such a critical need from a materials or process, okay? So, we have to understand that. We are talking about rationalization. We have achieved to some extent. I don't think we will achieve many more on that, okay? Still, aerospace will demand hundreds, thousands of alloys. You can't be rationalizing to 10, 20 going forward, at least for the civil, okay? Defense still you can do. So, considering that challenge, coming up with the collaboration between different agencies, tier 1, tier 2 suppliers, I think that will at least address some element of MOQ requirements, okay? So, that's another thing. And again, for the certification, always people think or get worried, okay? Certification takes time, lot of tests, lot of stringent norms and repeatability, okay? But that's what aerospace is, correct? Aerospace is mostly safety and reliability, nothing else than that, okay? And again, if you consider defense, we say mission critical, civil it is safety critical. So, when you develop anything for both of these, you have to have both elements in hand, okay? So, with those, I think we are stepping up and I'm sure we'll get there, but it has to be a collaborative effort. Thank you.
Thank you, sir. Dr. Subhash, thank you. And I would like to ask you as to from a ministry's perspective, although there have been a lot of provisions already set out in the DAP and other areas in terms of sourcing materials from indigenous suppliers, but what more can the ministry do? There was a bit of talk about having a kind of an incentivization scheme for the aerospace and defense material to be indigenized and produced in India, primarily to bring about processing capabilities and manufacturing. But as from a ministry's perspective, what can the MOD do to enhance and streamline the roadmap for self-reliance in materials for aerospace?
Yeah, no, I think this is something which is very crucial to the development of not just the aerospace but the entire defense manufacturing sector. And I remember when I used to be the secretary, thanks to my discussions with Mr. M.K. Gupta, who's here, and the PhD CCI, which really took this forward. We had set up a committee which came up with a set of recommendations. I understand some of them have already been acted upon. But, as you go forward, you have to look at the emerging scenario. And the emerging scenario as we see it today, as was actually pointed out by the representative from Midhani, we need to bring in these elements of the duty structure, etc. But from the perspective of, to incentivize, as you said. But most importantly, I think we need to take note of the fact that, this overall thrust for the Make in India approach will generate a huge opportunity within the country, not just necessarily for exports. And therefore, all agencies, I think, need to be to come together, including SEMILAC and the standardization, the quality assurance industry, of course, to come up to not only take stock, sector-wise, what is the requirement and where we need to plug in. Because, transfer of technology forms a very integral part of this entire cooperation. And I have had any number of opportunities to push with various suppliers from various countries, even under the offset program, to look at actual manufacturing. And I think the present government is really giving a thrust to this. So use of offsets actually should be seen as an opportunity for us to bring together a sectoral approach. Overall, I think, as you said, the Department of Defense Production will have to sit with industry, will have to work sector-wise and identify products which may be required for the aerospace, for the overall defense sector, including from the ordnance factories, from the armaments to the aircraft, the entire gamut. Only then it's going to work. And I think this must be done in a time-bound manner. Yesterday, the Honorable Minister said that, they are treating this year to be the year of reforms. I think this could be an opportunity for that. And as part of the reforms, there has to be an approach not just, to look at only the specifications and the support you can get from standardization, but also from the overall perspective of, the tax structure, duty structure, incentivization. I think that needs to be worked upon.
Thank you, sir. Absolutely. And reforms are very, very important. And as you said, that this year has been brought about as the year of reform. So it's very important that we need to reform ourselves in terms of policies and everything across the vertical of aerospace defense. I'll move to Sri Rohit from Yantra. Sir, as all of us are aware that the Indian ordnance factories have one of the have one of the best advanced infrastructure in terms of capability and everything. So what is Yantra doing to incorporate, if you could throw some light on Industry 4.0 capabilities in terms of material production, and what are the new things that Yantra has done specifically from a point of view of aerospace materials?
Thank you, Valpreet. Good afternoon, namaskar everyone. As far as Yantra India Limited is concerned, as you know, Ordnance Factory Ambajari is basically located in Nagpur, and it's one of the flagship company of erstwhile Indian Ordnance Factories, which had 41 factories once upon a time, but it has been now disintegrated to new 7 DPSUs, and Ordnance Factory Ambajari is part of the Yantra India Limited. Yantra India Limited basically is the catering for the hardware manufacturing of all defense product, catering from the barrels, tank ammunition, then the your hardware manufacturing for gun and all these things. But in the recent years, we used to do only for our in-house requirement, but for a couple of years, with the help of HEL, then CIMELEC, led by Dr. Anil Kumar Saab, he is the leader for our this effort for last couple of years. So far, more than 200 different components we have indigenized for different units of HEL, covering 6-7 different kind of grade of material, mostly aluminum extruded product. I think some of you may be aware, Ordnance Factory Ambajari have India's biggest extrusion press, that is 6,500 ton. With up and downstream facilities like from the melting to homogenizing, casting, then solutionizing, then control stitching and aging and all. So the most important that control stress material, that is mandatory requirement for the aerospace material, that one-stop shop solution is with us. But with the Atmanirbhar Bharat Abhiyan of Government of India, stressing for the self-reliance, we also already gear up our modernization process, and we are in the process of acquiring 10,000 ton capacity extrusion press with state-of-art up and downstream facilities, right from the melting to our your aging, control stitching, and all further downward your facilities. So we hope, as of now, as far as extruded product is concerned, around 60-70% we could meet of HEL requirements, and still 30-40% we are lagging behind. It's because of capacity constraint in the sense of your safe and the press capacity and the extrusion stretching capacity and all. With this, I think around 900 crores we are spending, and already our tenders are out. Maybe down the line, 3 years down the line, we will be able to install all those modern facilities with industry 4 capable plant and machineries. And we are not only catering for the our indigenous requirement, we are also looking for the export requirements, like for Boeing, Airbus, and all other your international players, and we are getting inquiries also. But right now we have certain constraint in capacity. That's why we are only concentrating on the indigenous requirement. So the coming that infrastructure, whichever we are already selected, and now it is under procurement process, will be fully equipped with state-of-art technology and with the latest QF4 features and your Industry 4 features. Thank you very much. Thank you.
Thank you, sir. Due to paucity of time, I'll just quickly move to Dr. Chandrasekhar from SASMOS. Sir, if you could just tell us what SASMOS is doing in terms of materials that are used across both aerospace and defense, and what are certain issues that as an Indian private player do you face in terms of material indigenization?
Okay. First of all, SASMOS does not use the basic raw material what we are actually talking about in this particular segment. But we do a lot of parts for Boeing as a metal parts, which we really do it as a company which is called Glodesi in our leg, which we really developed a lot of parts for F-15, F-18, and many of the aerospace grade products. But we are only importing those things as a component, I mean as a material. As a material we are importing. We are working with many of these subcontractors who are all actually supported by us as a consolidation approach of actually buying the material by ourselves and then giving it to them. But I think personally what I feel is there are many more components which we use do require aircraft grade materials, because of which localization is not possible because this is not available. So I think many of the panelists already said couple of points that I want to bring it here. As a country, in our opinion, and my personal opinion, I think there is a need for consolidation approach compared to 10 years before to now. A lot of things have changed from HAL being dominated in the aerospace industry. Right now as a subcontractors, there are many and much more materials are being used by private sectors due to Airbus, but it is all in pockets. Every one of us are trying to address our needs only by pockets. So in my view, I think one small benefit of SASMOS taking a small step in building up this for a raw material imports as on today as a consolidation approach has already given a very good level of supply chain benefits both in cost and also from the perspective of lead times. Whereas actually as a country, I think it's a huge potential. If we really put a consolidation approach first for these special materials, what is the requirement? Then I think, like as already the ministry has presented, there are many opportunities to create such kind of in-house, in-country opportunities to build it as a capacities. So today I think from pockets to consolidation is the time where it makes us to know and then become much more self-reliant in terms of meaningful business proposals for such kind of a requirement. So in my personal view, and then also as a SASMOS view, I think once this raw material comes up into the country, as a subcontracting and subsystem people, we can really develop many of the components in India, which is another set of missing opportunity in my opinion, which is really a big opportunity compared to only the big, I would say the metal works that we do across for aircraft. I think there are many small and important items which we really can create a technology into our hands. So from the raw material perspective, I see two things as an entrepreneur. One is if it is there, you can do a lot of things. To make it there, I think we need to consolidate as an economical benefit to solve all the problems of MOQ or anything. And of course, the leaders like HAL or somebody in a private side also can take a consolidation approach, and that will be really a great step for the country and for all of us, for sure. Thank you.
Absolutely, sir, and thank you so much for that. My final question would be to sir regarding how, so if you could just briefly tell us how Exim Bank can work. Exim Bank is obviously doing a lot of work in aerospace and defense, but from a materials point of view, how can Exim Bank assist material manufacturers in India? If you could just throw some light on that.
Yeah. Thanks for having me here. Amongst all the technical experts, I am the only one who's non-technical, but try to, see Exim Bank, as one of the panel members said, make in India, make for the world. So that's where we also vouch for. In fact, see, the indigenization is the, the start of that. In fact, and then export is this is where we are targeting to achieve. So if you see our exports figure, in fact, it's substantially in the defense sector has gone up almost around more than 20,000 crores last year. So that's all shows that, with the indigenization, it's very well possible to make the exports, grow the export in the sector. Understanding the, challenges of the sector, because this sector requires special focus in terms of financing. It requires a lot of R&D activities, not only in the material science level, but the component level as well. Because we work with many of the tier 1, tier 2 suppliers of, like, let's say Boeing, Airbus and HAL, BAL, all these guys, we work very closely. And many of our, supported, in fact, companies, mid-size companies are there and exhibited there in their exhibitions, in fact. So 3 years back, we launched a program called Ubharte Sitare program, Understanding the Need, wherein it's primarily, these are, this Ubharte Sitare program is primarily to support those stars, who are champions. In fact, we wanted to make them, a bigger champion in terms of global champion. So under this program, what we support to these, the tier 1 suppliers of the large players, in fact, like Boeing and all, because they require a lot of R&D, support. So they require a patient capital in terms of, their R&D activities. So in terms of patient capital, what we did, we gave them a long-term funding under this. We also provide equity to many of the small, medium-sized company. In fact, many of the drone, one of the classic example of the drone company, we work very closely with the, incubation centers also. When I was talking to some of the supported, before coming to this, in fact, event, that how, you guys can be more supported by the larger player like HAL and all. So they were suggesting that, in fact, if HAL can, because they are HAL or Boeing, or they can create an incubation center like what IITs and others are there, though they are supported, in fact. But it should be more kind of, the more, I would say, proactive approach from their side. They can provide their facility where they can do a lot of R&D activities in their facility, use their own, infrastructure. Because for these small, medium-sized company, initially building the infrastructure becomes literally a challenge for them. So rather than, because they have the talent, they have the talent pool, they can develop in terms of this aerospace material as well, which, my fellow, panelist, he said that as of now, we are majorly dependent on the import side. So that's focus is there, in fact, wherein we are very well placed to, in terms of financing. We are looking at, supporting under this program. We have supported more than almost 100 companies, and we look forward to supporting these companies henceforth as well.
Thank you, sir. And I totally get your point on financing, because this being certain aspect, specifically materials, which requires very high investments and everything. So that's where your role is very, very important for material manufacturers. Now, I would request although we don't have much of time, but we could take one or two questions from the audience if there are any questions. Surely, ma'am at the back.
Hello. Thank you. Hello.
Yeah.
Good afternoon to the esteemed panel. My question is with regards to the offsets that sir just mentioned. I am a media personnel and I cover policy related to offsets specifically. I want to know what do you think should the changes be with regards to the DAP in the coming time, especially as we are looking at a year of reform in 2025, and also to Exim Bank. How do we feel that Exim Bank can play a part with regards to local Indian companies cooperating or collaborating with foreign partners? Thank you.
Thanks.
See, as regards the offset policies, it is very clear in the DAP as well as in the policy itself that the opportunities are there in all the sectors. However, our experience has been that most of the offset partners have been unwilling or unable to get into this sector because of restrictions on them in sharing of technology. These are issues that the government takes up on a regular basis through the intergovernmental arrangements that we have with those countries, and also in the MOD set up forums where we also have interactions with various CEOs of companies. Now, this is something that is obviously going to take time because it involves issues of IPRs and other issues which they are not able to share. But as I said, as a policy, if we move forward and if we keep pushing it, we hopefully will be able to, generate, that kind of an approach to the sector itself. So far, we had not been focusing as much on the indigenization of all these materials, but I think now a time has come where we should all give it a push. As regards the banking issue, I think our friend from the other side will be able to answer.
Yeah, thanks. If I understood it right, the JV overseas, company forming JVs with the Indian company. So we are very happy and in fact open to supports as long as it's an Indian company. We don't have any challenge in terms of whether the shareholding comes from the overseas or the Indian counterpart. So as long as India registered company, so we are open to support them. The only challenge which I see of late, in fact, because of the defense contract, some of the defense contract requires ownership structure, certain percentage from the Indian citizens. So that's shareholding structure requires. So that's the challenge which they have. But from the Exim Bank's perspective, in fact, we are agnostic, as long as it's an Indian company, in fact. Thank you.
So, I'm sorry we won't be able to take any more questions. So we can take it. Okay, sure, please.
Thank you, gentlemen. My name is V.K. Kannan, Director of Space Systems from Aidin Technologies, Bangalore. This is a question to the Mr. Udani, I don't remember his name, the second gentleman. Yeah. So we have been in the aerospace and defense business for the last 16 years. We are MSME, and we do supply a lot of sub-assemblies to the satellite. And also we also the in-house design development products for the Indian Navy and also the PSUs like bell and other things and also. So now my question is, we have indigenously developed, designed a magnetic torquer, which can be a flight model. So already all the designs are over, and unfortunately we are importing the nickel alloy from USA. Now the quantities are like 10, 20. We already developed 20 numbers already. Now the quantities are likely to go up with the government of India opening up the space number of satellites, almost 53 satellites for the next 5 years. So we have been proud enough to fly this model in the next few months. This is the Amnesia satellite. So he mentioned about the MOQ issue. So I'm quite concerned about that. Our quantities could be like 40, 50s, and the maximum 100. Depends on how these 53 satellites from the ISRO as well as the various the private sectors who are going to build the satellite. We want to give the solution to all these people. So how this MOQ issue can be solved? That is my question to you. We definitely want to indigenize this, take an indigenous product of the nickel alloy instead of going to USA suppliers.
Sir, we are open to supply like company like you who requires a small material. But issue comes, the MOQ, what you said, but we consolidate all requirements if it is a, actually that's, if it is a similar requirements. And like if you're talking about the space requirements, that magnetic material is Perambadur, Softcom 49, what you are looking for, that we are regularly supplying. Some quantity you want, we definitely will be able to supply you. Only issues comes with the certifications. That will take care part of it, because if it is a space, yes, we can supply it with Midani certification. If it is a airworthiness certification required, that process has to be sorted out, because recently also we are facing a certification problem for supplying a small companies which are tying up with HAL and which tying up with ADA for developing a components of subsystem level. For this they require airworthy materials. That clearance of, we discussed with the DGQA yesterday. We are trying to sort it out. But space requirements, we are open. You can contact me any point of time. We'll supply to you. Yeah. Thank you.
Thank you, sir. So may I request Shri Chawla sir to just sum up.
Yeah, it's quite interesting panel I could see, and I think I'm seeing here the full breadth of the dais is covered by the panelists, and this is what shows, the interest in this area. And I'm very happy that a lot of, inputs are coming, and though a lot of work is being done concurrently, industries are coming up, and if I sum up, as I want it, there are one or two commercial aspects Midani brought out regarding that reverse, duties. On the components it is not there, but on the materials it is there. That of course we have to take up with the government, that's to make it more attractive for the Indian companies to invest and produce Indian materials. That is one thing which probably is required. Custom duty also can be more on the imported materials so as to encourage indigenous, these are the commercial aspects. We are more in technocrats area, but of course industry can take up through their forums with the appropriate authorities. Now coming to technical aspects, what I could see is that like major users like HAL or DRDO or BrahMos, they can put in more number of development orders on MSMEs and the new industries which is coming up. So that, they can develop whatever single lot or two lots for certification, which in the long run HAL will be taking the benefits of getting the deliveries faster, getting it cheaper in due course. So that is what probably is coming out, that our end users, probably, they should not be waiting for industry to get certified and then only, buy it, and waiting for L1 kind of a category, but parallelly they can place some level of development orders. The success rate may also be, limited. You may be succeeding in may not be succeeding in all cases, but that kind of a risk probably our end users, the main contractors, they can take for the items which they feel they will be requiring in the long term, as also there can be dearth of supply from their OEMs. Already we are finding, somebody has brought out that European is facing a power crisis. It's difficult for them, deliveries are taking more time. So you cannot be struggling. We are already struggling with a lot of our indigenous projects for want of components, materials and all. So that is one area where HAL and main contractors, even DRDO labs can look into. Dr. Kale has brought out on the certification aspects, we need to have, the industry should have smaller furnaces. We may not be producing in tons. maybe 250 kg furnace or 500 kg furnace in your R&D setup will be the best option, where you produce, develop alloy and try to, get it certified and then scale up based on the actual orders, or as also getting the export orders. So this is the area where industry can look for putting on small, furnaces. Maybe 250 kg also is a good enough for particularly aero. Yes. He also brought out the documentation requirements. We cannot be, the requirements for documentation, traceability, these are very vital in aero materials. We all fly aircrafts, we don't expect a material to fail. So this is where industry probably is felt that our Indian industry is lacking to the extent the foreign counterparts. So here the industry should see that the level of documentation, traceability, log sheets, heat treatment records, all those are, to extent automated to industry 4 level is a wonderful thing, is the best thing. But at least those things are, they cannot be compromised. So this is the area where I feel industry has to look into. Now rationalization and standardization is very vital. And in that thing, I think Boeing has brought out, whenever industry is taking up development, let them consolidate. Not only develop for HAL, you can seek, you are developing certain alloys. You can ask for BrahMos, you can ask for ISRO, or you can go to Boeing or Airbus. Okay, this is what area we are developing. Probably you may have the similar requirements, or you may broad-based your specification to cover more category of alloys, to make it more economically viable. So that's a good suggestion which has come. And not only, what I feel, as an offset of that, may not be not only defense for aeronautical use, we may, use for even naval and army applications. Maybe a certain alloy may be over-designed for a army or naval application, but probably cost-wise and other things, it may be economically still viable. I think this is high time we can also look for the overall defense requirements, and not only defense, why can't even railways or the major bigger users. So I think there the MSCC industry can take up this challenge and probably reduce the variety of, already 2,000 alloys we have developed, but the quantities required are hardly much. So I think that is the need of the hour, where I think PhD chambers can further consolidate the alloys requirement. That can go in a long way in our indigenous efforts. I think that is what probably I could, see that consolidation, and these are the inputs which we got. And I'm happy, and I think seems to be satisfied that number of good inputs have come. And the way forward, I think the road ahead for all of us is coming. So thank you all. Thank you for your participation and active participation. Thank you.
Thank you, sir. I thank all the panelists, and may I please request all the panelists to please join for a group photograph, please. Thank you so much, everyone.
Check. Can we please clear the stage? Ladies and gentlemen. No, it's one. It's one.